Good morning and welcome to my presentation. Thanks very much for coming. I know it's the last day of the conference. We're getting a little bit tired, but I'm glad that you're still awake and still interested here. So my name is Ahren Lehnert. I am the Senior Manager for Text Analytics Solutions with Synaptica. I've been working in taxonomy, content management, search, and text analytics for about 15 years. I started with Synaptica just in March. I was brought on board to work specifically on text analytics solutions based on our experience with taxonomy management since we've been operating in that space for over 20 years. So I'll kick us off with some working premise. And first of all, before I start, I'll say, I feel like my presentation is a bit weird. But then I started to think, if you're at the Text Analytics Forum, maybe you're a bit weird. I'm kind of hoping. So maybe some of this will resonate. So anyway, my first working premise here is that we fear the potential of our machine overlords. I've been thinking about this David Bowie song, and so here's a quote from The Savior Machine. President Joe once had a dream. He told them his scheme for a savior machine. They call it the prayer, its answer was law. How they adored it till it cried in its boredom. Your minds are too green, I despise all I've seen. You can't stake your lives on a savior machine. A bit dystopian, a bit gloomy, but we'll keep going here. Despite fearing the potential of our machine overlords, we are trying very hard to create machine overlords. And here we have some examples of some of our machine overlords, including HAL 9000 and Lawnmower Dog. If you're not familiar with Lawnmower Dog, we'll circle back on that. Working premise number 3, despite trying very hard to create machine overlords, we still have a long way to go before we actually create our machine overlords. And I found a very good Tech Republic article that I'd like to quote here because I think it sort of sums up the whole premise of my talk. As much as we may want to go, quote, all in on machine learning, most companies haven't even figured out how to de-silo and clean their data or do basic analysis of that data once the preparatory work is complete. Without that initial step, no amount of machine learning software will magically transform a business. Instead, it will cause enterprises to question the machine learning investments in the first place, rather than tackling their approach to machine learning, which is really the core problem. So my emphasis in bold is really kind of the core of this presentation, is talking about the preparatory work. And I've actually really seen this in practice where machine learning failed, and it wasn't necessarily the machine learning, it was all the prep work and things that went into it. So I stole this very wonderfully simple graphic. It summarizes the steps in performing machine learning and predictive modeling. The author here has 5 steps: getting the data, cleaning, preparing, and manipulating the data, training the model, testing the data, and improving it. So I am going to make a confession. I am not a strong expert in machine learning, so I'll only focus on the first 2 steps here, which is getting and preparing the data. Getting the data and cleaning, preparing, and manipulating the data are where taxonomy and text analytics really play a role. Okay, so the savior machine. Again, so I thought this was a bit weird, but yeah. What does it have to do with machine learning, taxonomy, text analytics? Artificial intelligence, machine learning, we've obviously been hearing a lot about this. They're kind of buzzwords. We're getting into it. Some of us really deeply understand it. A lot of us do not deeply understand it, and we're all trying to find our way in this. I started thinking about this Bowie song, The Savior Machine, and how this artificial intelligence, if it could speak what it was really thinking, might lament over our willingness to accept its prognostications as truth and say, quit listening to me, perhaps. Maybe I'm not giving you the proper information. So I made that obvious leap from HAL 9000 to Zardoz. If you've never seen Zardoz, I highly recommend it. It's got Sean Connery running around in what equates to a diaper. That's one incentive right there. I don't know what else you need. So here is Zardoz, the savior machine, giving us what we think we want. Answers straight from this floating head's mouth. And somehow these answers are coming without any data preparation. They're mystical, they're magical. You plug it in and this thing just feeds you insights. Well, that's not really, it's not really how it works. So is anybody here familiar with Rick and Morty? Few people. All right, yeah, I was right. You guys are a bit weird. So Rick and Morty, what we have in Rick and Morty is this floating head comes to Earth and it says, show me what you got. right? And what they do is they feed on the talent and the showmanship of less evolved life forms. So I'm going to venture a statement here that machine learning is more like a cromulon than Zardoz. It demands that you show it what you got, rather than dictating the answer from its own unsupervised learnings. So machine learning, you could say, feeds on the talent and showmanship of their less evolved creators. And if what you got is garbage, machine learning isn't going to work very well. So we believe that we can put garbage in and get gospel out, but more often we are putting garbage in and getting garbage out. So as I confessed earlier, I'm not a deep expert in machine learning. However, I think we should cover some of the basics. Maybe some of you are beyond the basics, but I'll just do a couple, have a couple points here that I think is important to, oh, I lost my notes. Hold on a second here. Important to my presentation. Sorry, I'm losing my notes here. All right, so the first thing that we need to talk about is that machine learning needs big data. Apologize. Okay, data is typically structured, or it is structured from unstructured text. Big data, according to Gartner, is high volume, high velocity, and or high variety. Machine learning needs good examples. Machine learning works best with supervised learning training sets. Machine learning requires clean, accurate data appropriate to the problem we are trying to solve. And if you have good examples of what you're looking for, it can predict future examples which fit the profile. Machine learning looks for patterns. So if you have wildly inconsistent, far-flung data, it will increase the number of patterns it picks up. So the more patterns you have, the more noise you have. Machine learning learns from experience. Machine learning is, by definition, improving with experience at some task. The more experience it has, the more it can improve at the task. And finally, machine learning takes time. And I think this is one of the most important parts. Don't expect a plug-and-play win with machine learning. We hear some of the promises, but it takes some effort. So here we are. We are back to our cromulons of machine learning. Show me what you got. If what you have is very unstructured, it's very unclear, you've got nothing. As taxonomists and text analysts, which a lot of us I'm sure are, we know language is extremely messy, inconsistent, it's rarely clean or straightforward. So the inherent complexity of language is one of the problems that goes into machine learning and where text analytics and taxonomy can help. So let me give you an example. I'm a swimmer. I don't know if there's any swimmers in the audience. I swim in Pacific Masters. Here's a picture of, this is my pool, not my pool, the pool I swim in. And I took a picture of this chair because I found it really funny. It was marked pool. And I thought, well, first of all, it's not a pool. And second of all, it's not even a pool chair. It's a chair at the pool. And you could say it's the pool's chair, assuming a pool could own a chair. You know, here we've got something labeled a pool, which it's not, it's a chair. And we've got a pool that's not labeled as a pool. All right. Simple, kind of silly thing here. We know what these things are, but you know, you get the idea with text analytics machine learning, you know, how is it going to figure something like this out? So what? So let's go back to Zardoz here because, well, Zardoz is extremely weird. So if you show machine learning a chair, a pool, a chair at a pool, a pool chair, how does it know the difference? I've really done a very simplistic sort of model here where I'm substituting images for text to start off. But if we feed in a bunch of examples, it will use learning algorithms and it generate a model. And this is a fairly simple machine learning problem where it's just classifying. And it's saying, you've given me a bunch of examples. Here they are. I've sorted them out for you. In supervised learning, unsupervised learning, if we give it a bunch of examples that are not so clear, and in this example I'm going to give it a bunch of tweets. Tweets are messy. It's language, but it's sometimes it's hardly even language, right, with tweets. So you give it a bunch of ambiguous information. It uses its learning algorithms. It generates a model. And in this case, it's decided, well, the only thing I really recognize here are swimming pools, so it's all about swimming pools. It's missed the fact that in these tweets, we had swimming pools, we had betting pools, we had mining pools, we had natural pools. Why? Because somehow this model is generated and said, well, the only thing I really recognize is swimming pools. So this is what happens when you are disqualified. Oh, whoops. So here's your machine learning endeavor, your business, and your entire planet coming to a fiery end. It's very unfortunate. So we have to ask what happened. Possibly we fed the machine learning model inaccurate, inconsistent, or insufficient data. This is often a symptom of multiple disparate sources of data, which include multiple versions of an idea or concept. And quite frankly, finding patterns in this kind of inconsistent data is very difficult. Variety doesn't necessarily mean it's bad data, but it can mean there are multiple ways to describe the same idea. So sometimes that's even worse than just having messy data. It's inconsistent because it's a variety of data. Data scientists, and this is I've seen this in practice, and I think this is really critical. Are there any data scientists here? You guys are very expensive, and having a data scientist spending all of his or her time cleaning up Excel spreadsheets to get the data prepared to fit in the model is a complete waste of time. And if I were a business owner, I would say, why am I hiring this extremely expensive person to do very low-level kind of cleanup when I should be paying them to do what they do best, which is data science, right? Machine learning is very complex. For many of us, it's a bit of a black box. We don't really know what happens, so sometimes it spits out answers. We don't really know how it arrived at it, and we have to sort of backtrack and find out what was going on. And finally, back to my main sort of premise here, unstructured text is very difficult. There's a lot of prep work involved in getting this right so we can get insights out of it. So I really like this slide, however, in the interest of time I have to skip it. I'm just going to say that the one thing that's important here, clearly define the problem. Okay, we got people, process, technology. I've got all these arrows around. If you want to talk about this more, we can. But the problem needs to be defined, and that's one of the key things to know. So if we move forward to knowledge engineering, so using taxonomy, text analytics, and machine learning provides an ecosystem. We use these three things together. Okay, so it all starts with the content. Content is the basis for the work that we do. We can't forget that it's about the content, honestly. This is why we spend time building taxonomies. This is why we spend time analyzing text. And text analytics is really our first workhorse. We're plowing through all of that content, trying to extract information, trying to make sense out of it. It allows us to process large amounts of information, and we can use the text analytics software to cluster known and unknown extracted entities from content and map these back to known taxonomy values. So taxonomy. Taxonomies, as we know, provide the centralized controlled vocabulary that you can apply as metadata back to your content. Taxonomies, this is all sort of a circular workflow. We build taxonomies from what we know. We also build it from what we don't know, the unknowns that we extract from the content. And another thing that I think are important about taxonomies is that they provide often, for most of us, an understandable business layer for interpreting our content, right? We've got this hierarchy, we can navigate it, we can look at it, browse it, and understand what our content is about. So machine learning is our second workhorse. This is processing all of that extracted information from the content itself. It provides the algorithms, the learning models to process all this. And machine learning is also very scalable. It likes big sets of data, as I mentioned before. All right. That was interesting. So let me give you an example of something that I've seen done. I've done some work with this. So I was in a marketing department, thank you, where there were several different taxonomic structures coming in, and some of them were internal and some of them were external, and they were all over the board. They were from multiple vendors, and we're talking multiple taxonomies, and they were uncurated because they were coming from externally. We couldn't own the taxonomies coming from outside. I mean, all you have is, once you get it inside, what do you do with it, right? So we were taking these external, these are, obviously very simple versions of a taxonomy to get the point across, but we have these different taxonomies, and we wanted to sort of map them together. Now, we could do this manually. That is time consuming. It's painful. So what we were doing was throwing all these taxonomies into a text analytics tool and using that to cluster all these concepts and group them together and then map them back to a common taxonomy. And then you can feed this into our machine learning, and it will be able to classify what's coming out the other end. Okay, so concept clustering. I think this is very important. So a lot of text analytics, this is not particularly complicated actually for a lot of text analytics. It's you are putting together the concepts, you are clustering them. And you can do this multiple ways. I mean, one easy way really to do this is to say, well, if the terms are similar, if they have some kind of root word, that lemma, you can cluster them pretty easily. So if you have multiple sources of information, you kind of cluster these things and you create basically these zones of common words, and then that way you can start to map back to a common taxonomy. So I'm very much a big fan of taking things, breaking them into their constituent parts, and sort of putting them back together for mappings. I think it's a very useful exercise. Okay, so let me show you some process text here. Now, I gave this presentation in London, so this is about Peaty. Adam Peaty. He's a breaststroker, a British breaststroker. I thought that would impress the audience, but I didn't change my example here. So this is about Adam Peaty. I didn't switch it to Phelps. I know. But what we can do is we can process this text, we can analyze, we can match against entities that are known, we can also extract entities that are unknown, and we can map them this way. Now, in a situation like this, we have multiple taxonomies, and we can say, that cover a variety of subjects, and we can map, okay, well, here's our person taxonomy, here's our subjects taxonomy. We're picking out all of these elements. What I'm not finding in here is that I also have a taxonomy that's got swimming pool reactors. Well, that's okay, it's got swimming pool in it, but it has nothing to do with swimming and swimmers and men swimming. So, what do we get out of this? First, I'm going to start with the bad news, the losses. Using this kind of method where we're taking taxonomies and clustering and then grouping together, there's a lot of time and planning involved in this. And I think that's one of my key points, is that people think it's plug and play, and probably a lot of you know that's not true. There's a lot of work that goes under the hood to get it to work. And so you see the end product and they're like, it magically does this. It magically does this after thousands of training sets have been thrown into the tool and taxonomies have been built and we've done all our mapping. So I think it's unfortunate. We can speed these up, we can automate some things, but there's a lot of work involved in getting these set up to get started. And I'll admit here that in this kind of environment, you're really artificially constraining yourself. You're saying, I have known taxonomies, I'm mapping to another known taxonomy, these are known values. This is not exploratory work. This is just dealing with the knowns. And sometimes that's all you need. Deal with the knowns, and then you can deal with the unknowns and pull them back into it. Okay? And again, unstructured text is by nature full of uncertainties. You see examples from text analytics vendors and any kind of machine learning, and they'll say, well, it works great in this example. Well, it works great on scientific literature, it works great on news, but these are sort of controlled kinds of environments. When you start dealing with Twitter and tweets and that kind of stuff, it's very messy. Okay, so what are the wins? Let's talk about the good news. The wins are, and data scientists like to hear this, you can spend more time doing actual data science. We can get our bang for our buck out of you because, again, data scientists, highly skilled set of background, and we want them to be doing data science, not cleaning up Excel spreadsheets. Another win is that it provides an infrastructure, an ecosystem for extracting new concepts and then feeding them back into the known. So we get this known-unknown loop that we look at the unknowns, we feed them into the knowns, and then we can apply it to the content we want. And it provides an infrastructure that can be used in other applications. That's a key one. We can use it in search and knowledge management. And scalability. Text analytics and machine learning bring a lot of scalability to your content in order to process it. So, in summary, and this is almost my last slide here, so we're all set. I can't emphasize this enough, even though I kind of went over that slide a little quickly. Have a defined problem. If you don't know what the question is, how can you answer it? You can't just buy tools and go, tell me the truth, Zardoz, give me an answer. No, you have to have a question, define it, and maybe you'll get insights out of it. Second, get a grip on your content. If you have uncontrolled content, you need data, content, knowledge management, you need governance, you need those processes. And finally, don't expect a magic fix. I think a lot of the vendors here, including ourselves at Synaptica, we're trying to be very honest about the amount of work you have to put in. We can promise magic fixes, but we know that there's work to be done, but the result is often worth all that time and effort. So, and remember that any good solution is going to include a mix of people, process, and technology. And so the Cromulons, they like what you got. And so you've saved the planet, and you can do your happy dance because your machine learning endeavor was a success. If you have any questions, I'm going to be here out in the lobby for the rest of the day, and I'd like to thank you very much.